Hello students, welcome to ATC. In this video, we will see some more examples of DFSM designing part. So the question number 3 here, the question goes like this. Draw a DFSM to accept strings of A's and B's having exactly one A. Okay, having exactly one A. So you know the steps now. Let us see some valid and invalid examples. So exactly 1A means you should have minimum 1A. So 1A I have written, that is a valid example. Then I'm having some B's and I'm having 1A. Yes, it is valid. Now I'm having 1A, just 1A and any number of B's. So A can be either at the beginning or at the end or anywhere in between. So A, B. And now I have BA, so I have just one A, and I can have any number of B's, guys. See, according to the question, they have just given exactly one A. Since the strings consisting of A's and B's, I can have any number of B's. Okay, so invalid strings, I can't have two A's. Okay, similarly here in the second example, I have BB, so two A's I'm having. So here I have three A's and here I have many A's. So they're all invalid examples. Okay, now let us see how we can design the DFSM. So the minimum string is A, input alphabets A and B, skeleton DFSM, just like in the previous example, what we discussed in the previous video, it is Q0. Upon reading A, it has come to Q1. Okay, now we need to identify the other transitions. So what are the other transitions we have? That is Q0 upon A, like this. I think in the previous video also I showed that. You can just make a note like this. So Q0 upon A upon B. What is happening? Whether you have any transition. Now Q1 upon A upon B, whether you have any other transition. So every transition we need to define in DFSM. So Q0 upon A, yes, we have, that is Q1. And Q0 upon B, we have not defined. Q1 upon A, we have not defined. Q1 upon B also, we have not defined. Okay, so we need to we need to complete the DFSM here. So how do we complete the DFSM? First, let us draw the skeleton DFSM now. Okay, now I think in the previous video I said, and I repeat that whenever you want to complete the DFSM, try self loop first, then forward transition, otherwise back transition. Otherwise, you have to go with the trap state. I will tell you what is trap state. Now let us try with self loop upon, that is Q0 upon B. Now what is the question? Strings of A's and B's having exactly one A. That means I can have any number of B's at the beginning, right? So I can go for self loop. I can go for self loop upon B. That means at the beginning I can have 0 or more number of B's followed by A. Let's say one example like this. Okay, let's say BBA. This is a valid example, right? So B, again read B, then go to a final state. It has reached. Okay, so Q0 upon A is done. Q0 upon B is also done now. Okay, so this is done. Now what is left out? Q1 upon A and then Q1 upon B. Okay, so can we have Q1 upon A as a self loop? What is the question given? The question given is that it should have only one A. I can't have more than one A. So Q1 upon self, that is Q1 upon A as a self loop, not possible. Can we have any other transition in the forward direction? Do we have? No, we don't have. Okay. Can I put like this? Okay, that is backward direction. Can I have from Q1, can it go back to Q0 upon A? If I do that, that means what? A I am reading, again A I have to read so that it reaches the final state. But according to the question, I should have only one A. I can't have more than one A. So that is forward direction, self loop not possible, forward direction not possible, then even the backward direction is not possible. So what is the thing which is left over? I have to go for a trap state. Okay, so I have to have one more state like this. This is what we call it as a trap state, and upon a it has reached the trap state. Trap state means it is like infinite loop kind. Okay, so it is trapped, it is dead state, we also call it as dead state. Okay, and as soon as you write the dead state, immediately it will be a self loop with all the inputs. Okay, it will become a self loop upon all the input alphabets. Okay, this is a must because it can't go anywhere else. It will be as an infinite loop itself because it is a dead state. We are not going to do anything with this dead state, so its transitions will be self loop always. Okay, now I am done with q naught upon a, I am done with q naught upon b, I am done with q1 upon a. Now what is left out? I have to go for q1 upon b. So again try with the self loop. Can we have it as a self loop q1 upon b? Can we have any number of b's? Yes, possible, right? I can have any number of b's here. Okay, so I can go for a self loop. So this is the complete DFSM design. So q1 upon b is also possible. Okay, now if I try going with one more example, let me just take one more example. Let us say B A D B. Okay, this is one example, and we will check whether it is possible. I mean, like whether it will be accepted or not. B. How do you read B? This B. Okay, I am going and reading this B. This is done. Now A. So I will go read A. Now B. So this B. So it will be a self loop. It will be a self loop. Again, there is one more B. Again, it will be a self loop. And which is my state? Final state, Q1. So positive. Okay. Let me give one more example. Okay. A, A, B. Okay. Let us just try out with this. Okay. A. How do you read A? Okay. I will change the color. Okay. I will read A like this, right? Now A, one more A. So one more A, it has reached the final state. One more A, where will it go? It will go to the trap state, and then B, it will read. So where are you now? You are in the trap state. You are not in the final state. So this string is rejected. Rejected in the sense because I have two A's now. So that is why this is rejected. Okay, I hope the point is clear now. So you need to write down the definition, M definition, and then the transition table. So in the transition table, you know Q naught is a start state, Q1 is a final state, and Q2, though it is a trap state, you have to make a note of it here. Okay, and then upon A and B, what is happening? So this is your one question. Now let's go with the fourth question. Okay. Draw a DFSM to accept strings of A's and B's starting with the substring AB. So starting with the substring AB means I have to start with A followed by B, and then I can have anything else. So my minimum string is AB. My minimum string is AB, and then I can have anything else. Let's say A, B, anything I can have later. But it must start with A followed by B. We call it as A followed by B here. Okay, so valid strings, let us take some valid strings here. AB, you know, minimum string. Now see, look at this, it is starting with A followed by B, right? It is starting with A followed by B. I don't have to worry about whatever we have in later. Similarly, I have A followed by B, A followed by B. Okay, so valid strings. Invalid strings, as you know, it is starting with B followed by A. Okay, so not possible. Though I have AB here, it has started with B. That is not a valid one. Again, it has started with A but not followed by B. It has followed by A again. So not possible. I mean, like, you know, this is invalid. So it has started with B. Though this has started with A, it is followed by A again. It is followed by B, followed by B. So they are all invalid strings. Okay. So let us try what is a minimum string here. According to the question, the minimum string is AB. So the input alphabets are A and B. And let us draw the skeleton DFS. So minimum string is AB. That means A followed by B. So start state A followed by B. Then only it will reach the final state. Okay. So this is your skeleton diagram. A followed by B. Okay, so now let us try to complete the DFSM. This is my DFSM, skeleton DFSM. You know what are the transitions we have to do? Okay, that is we have to have Q0 upon B I should have, then Q1 upon A I should write, then Q2 upon A and B we should have. So these are the transitions which are left over here. Okay, now let us find out that what is the question. It must start with AB. It must start with AB means, can we have Q0 upon B as a self loop? You know the order. Can we have it as a self loop? If I have it as a self loop, that means my string can start or begin with B. So that is never possible. So I can't have B as a self loop here. This is not valid. So can we have forward direction? Suppose I have it as a forward direction. Let's say something like this. Okay, if at all I have it as a forward direction like this as B, then my string will will start like this. B B, not possible. Okay, it should not start with B at all. Okay, so it is like a small tip for you guys. Whenever it is like say starting with something, okay, then definitely you will have a trap state, because one of the inputs has to go to trap state. Okay, because it must begin with something, right? It must begin with something. So that is why it goes to the trap state. Okay, so Q naught upon B will go to trap state, and then it will be having AB as self loop. Okay, now this is done. Now I have to check with Q naught, Q1, sorry, Q1 upon A. So again, the same procedure. Can we have it as a self loop? You try out now. You write it and try, no problem. So Q1 upon A, if I write, okay, now what is the question they have given? It must start with AB. So if I write as a self loop, let's say my string would be A B. Okay, so I can have A, so many A's, and then followed by B. Okay, so this is not my valid string. It is not possible. So I can't go for self loop. Okay, can I try with forward direction like this, forward transition with A. Again, this is not possible. Okay, can we have it as a backward transition? Let us just try doing it now. A. Okay, A, 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 B. Look at this. A, 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 then B. Okay, A, 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 B. Okay, so what is my string? It must start with AB. So again, this is not possible. So we tried with self loop, forward transition, backward transition. Nothing worked out. Okay, so you must put that into a trap state. Okay, so Q1 upon A will go to trap state. Okay, now Q2. Okay, now what is Q2 here? Q2 upon A. Can we have, see, the question is, you must start with A followed by B. Later I can have any number of A's and B's. So we can have it as a self loop. Okay, so A, B followed by any number of A's or any number of B's. Okay, possible. Like, I think we took some examples like this. So A, B, A, B, B, possible. A, B, anything is possible. Okay. So A, B, A, A, B. It is in the final state. So similarly, let me have A, B, A. Okay. So A, B, A. So any number of times you can give, and it is still in the final state. Okay. So you have to draw the transition table accordingly. Okay. So the next question, draw a DFSM to accept strings of A's and B's ending with the substring ABB. Okay, ending with substring ABB. So according to that, some of the valid examples you have to observe here. It must end with ABB. So this is my actually minimum string. Okay, it is ending with ABB. It is ending with ABB. And some of the invalid strings BAB, so it is not ending with ABB. AB, though I have ABB here, it is not ending with ABB. Are you getting the point? It must end with ABB. So this is just ending with BAB. This is ending with BAA. This is ending with BAB. This is ending with AAA. Okay, so they are all invalid examples. Okay, so let us just try finding out what is a minimum string, that is ABB, input alphabets A and B. Now let us draw the DFSM, skeleton DFSM. So upon reading A, it will go to one state. Upon reading the next input B, it will go to the other state, followed by the next input B, it will go to the final state. So A, B, B, it will go to the final state. So this is our skeleton DFSM. Now we should complete the DFSM. Okay, so similarly, just like the previous example, we have to check out whether Q0 upon B, can we have it as a self loop first? So can we have it as a self loop now? Suppose I have it as a self loop. Can we have any number of B's at the beginning? Yes, we can have, because the string should end with ABB. It need not have to, it can have any number of B's at the beginning. It doesn't mind having any number of B's at the beginning. Okay, so I can have it as a self loop. Okay, just a second, guys. Yeah, I can have it as a self loop now. Okay, so the next one. Okay, what is the next one? Q0 upon A is done. Q0 upon B is done. Now we have to go with Q1 upon A. Okay, so again try logically. Can we have Q1 upon A as a self loop? Okay, what is the question? Ending with substring ABB. Okay, let us just try reading this one. Okay, I will take a different color now so that it is easy for you to follow. So let me read a string like this: B, B, A, B, B. This is one string. Let me just take it. Okay, is it ending with ABB? Yes, it is ending with ABB, right? So let us try tracing it out here. Okay, how do you read this B? Yeah, self loop B. Okay, the next input alphabet B, again self loop B. Now A. So I am reading A now. So B, B, A. Okay, now again one more A I have. So I'm having a self loop. So I can read one A. Now B, B. It has reached the final state. That means I can go for the self loop here. The self loop upon, that is Q1 upon A as a self. Okay. Now try out with Q1 upon A is done, Q1 upon B upon B is also done. What is Q2 upon A? Can we have it as a self loop now? If I have it as a self loop upon A, okay, my string would be A B A B. Okay, A B AAB. Any number of A's I can have. So it will not, end with ABB. So this is ruled out. I can't do that. Okay. So can we go for forward transition? Can we do that? Okay. It will become ABA. Not possible. Which is not possible. Can we go with previous states, that is backward direction? Okay. Let me try that. Then let me try putting it to the backward. A. Okay. Can we have it? Okay, let us just try A, B, A, B, B. Okay, okay, let me just try out this one. I wanted to check for B, B, A, A, B, A, B, B. Okay, since it is ending with ABB, the string has to be accepted. So how do you read this? BB, self loop. Okay, B, B, then A, 1A, then 2A's, so self loop, A, then B, okay, B, then A, so I can come back, A, then B, then B, it has reached the final state. Okay, so that means what? The previous, that is backward transition is working. Okay, so Q2 upon A is done, Q2 upon B is done. Now Q3 upon A and B. So Q3 upon AB, just like that, it has to try out with self loop. It is not possible. There is no forward transition. Try with the previous transition. If at all I had tried like this, if at all I had given A here, then my string would give A, B, B, A, B. So it is like this. A, B, B, okay, like this. A, B, B. If I have to come back, I should read A, then again the forward one B, then only it will reach the final state. But is it ending with A, B, B? No, right? So this is not possible. Okay, so this is not possible. In that case, what you can do is you try with the previous to that. Okay, that means previous to previous state. So if I put it here, it will be like A, B, B, A, B, B. A, B, B, possible. Okay. What about the same way? B, I can put it back to the first state. Okay, because self loop everything is not working, so I can put it to the Q naught state. So I will get the transition table like this. Okay. So the next question is same thing, but that do not end with ABB. Yeah, so it is similar to the previous question, but that do not end with ABB. So that do not end with ABB means I should have, it is just the reverse of the previous question. Just the reverse of that. So what you need to do is, it is opposite of the previous question. So what we need to do, we need to just reverse the states. Reversing the states means here, make final states as non-final states and make non-final states as final states. Okay, so this is what we mean by reversing the states here. Okay, so same thing I have given, but I have just made Q0, Q1, Q2 as the final states and Q3 as the non-final state. Okay, so I hope the things are clear here. Okay, thank you.